much. And yeah, I'm really, really grateful to you, Ryan, for inviting me and give me the opportunity to discuss this with you. As Ryan said, like I'm a first year PhD student at Oxford, and my primary research interest is infinity in ancient philosophy, especially in Aristotle. This is not really something that like the project I'm presenting today is something that like is not really within my specific dissertation project, but is somehow related to that. And what I want to talk about today is the famous or perhaps infamous paradox of the dichotomy. As you probably already know, Zeno used this paradox to argue that it is impossible to traverse continuously a distance that is infinitely divisible. Now, you might excuse me if I say that everyone with a sane mind would want to reject that conclusion, but as you know, it is not that easy to reject it philosophically, and it is still debated whether Zeno was right to some extent. For example, if we were asked to perform a sequence of infinitely many discrete steps, would that be logically possible? Now, what I find interesting and what I want to talk about today regarding this question from a historical perspective is that Aristotle, who is the first philosopher where we find a detailed discussion of Zeno's dichotomy, already saw the distinction between the two cases, so the continuous and the discrete, and agreed with Zeno actually that the second is impossible. So in this talk, I want to explore first the fact that he thought so and show like how that comes from, in particular, his second answer to Zeno's dichotomy, and then understand why he thought so, which is a much trickier and to some extent speculative endeavor, but I hope that makes sense. And the reason why I call this point of no arrival will become clear when I do the second part. So I'd say let's get started by briefly recapping Zeno's dichotomy paradox as it is found in Aristotle. I won't address here questions about the exact version of the paradox that should be ascribed to Zeno. I will mostly talk about what Aristotle thinks of Zeno's paradox. Now, as I said, Zeno wanted to show that continuous motion is impossible. To do so, he took a distance, let's call it AB, and showed that in order to traverse the line, one must also be able to traverse a sequence of infinitely many segments within the line, which can be obtained, for example, by dividing the line in half and then one half in half and so on, as you can see in the figure. And this is premise one. But he claimed it is obviously impossible to traverse infinitely many segments. This is premise two, and therefore motion is impossible, since like any motion should go over distances such as AB. Now, Aristotle discusses the dichotomy twice in the Physics, first in book 6 and then in book 8. In this first response, Aristotle denies the truth of what I called premise 2, that it is impossible to traverse infinitely many segments. And to do so, he relies on the fact that there is a correspondence between the distance that is traversed and the time in which it is traversed. If both are assumed to be continuous, once we grant that in the distance there are infinitely many segments, we also grant that in a finite interval of time, there are infinitely many intervals, in each of which each part of the motion can be carried out. Later, however, in the Physics, Aristotle reconsiders the problem, and he notes that the first solution only works if we think that the problem with premise 2 is a problem concerning time. Indeed, the solution shows that it is possible to traverse infinitely many segments in a finite time. But what if one thinks that premise 2 holds independently of whether there is enough time to traverse the segments? So if we think so, that approach is no longer sufficient, and we must find a more appropriate answer. And Aristotle sets out to do so in Physics 8.8. This time, he doesn't unrestrictedly deny premise 2 as in the first time, but instead, he wants to show that it contains an ambiguity, and the sense in which it is true is not the sense that is relevant to the argument. I will consider this more in detail now, and in particular, I shall focus on the passage where Aristotle spells out his revised analysis of Zeno's dichotomy, which I quoted here. I read it now. Aristotle says, therefore, it should be said to the one who asks if it is possible to traverse infinitely many things, either in time or in length, this is premise 2, that there is a sense in which it is and a sense in which it is not. Estin hos ou. Now, this is like Aristotle's classic formula for pointing out a case of a fallacy of equivocation, as he explains, for example, in Sophistical Refutations 19. And the ambiguity is the following. For if they are in actuality intelecheia onta, it is not possible. But if they are in potentiality dyname, it is possible. Now, this intrusion of metaphysical jargon, actuality, and potentiality might seem obscure. And Aristotle is saying that premise 2 is true if the segments within the distance exist actually, and false if they exist potentially. But what does it mean? I think it can be clarified considering some claims Aristotle made in a previous part of the chapter, where he talked about the structure of motions and their paths. Now, supposing that AB is always like the path of a motion, Aristotle made two crucial points. First, he states that the points internal to AB exist potentially if AB and the corresponding motion over it are continuous. And then conversely, he says that if a point internal to AB exists actually, the motion halts at that point and reprises after an interval of rest. Now, Aristotle doesn't say it explicitly within the chapter, but it's clear that the same holds for the parts of AB that are delimited by such points, as well as the internal points themselves. Now, these claims are extremely interesting for the metaphysics of parts and limits in Aristotle, but I don't want to be concerned about that right now. What is important to us is that they provide a way to spell out the ambiguity in premise 2. So given these assumptions, what Aristotle says that the object is moving along a sequence of infinitely many segments that exist actually, he means that the object is performing a sequence of discontinuous motions, each one being separated by the others by an interval of rest. And then Aristotle says here that is impossible. On the other hand, if the segments exist just potentially, it means that they are traversed as part of a continuous, uninterrupted motion along AB, in which case there is no impossibility. Now, the general solution is easy to understand. Of course, the same ambiguity can be found in premise 1 as well as premise 2. So a first interpretation of premise 1 is that in order for the object to traverse the distance, it is necessary that it traverses all of the infinitely many segments within the distance as existing actually, that is, in the way we have understood it, by performing a sequence of discontinuous motions. As we have seen, Aristotle concedes that such a process would be impossible, but that is not what happens clearly when we traverse a distance continuously. So the premise is false in this interpretation. Instead, to make the premise true, we need to understand it in the sense that in order to traverse the distance, the object must traverse all the infinitely many segments as existing potentially, that is, by performing a single uninterrupted motion. This is true, but involves no impossible process according to Aristotle. Now, for the rest of this talk, I do not really want to focus on Aristotle's general conclusion against Zeno, but rather on the point that he concedes to him. I restate this point now, avoiding references to potentiality and actuality. So what Aristotle concedes to Zeno is that it is impossible to complete a process that consists of infinitely many discrete steps or tasks, that is, to arrive at a state in which every task has been completed. I call processes of this kind Z processes, and the principle no infinite steps. That Aristotle is committed to this principle is quite clear, both from the response to Zeno we have considered and from many other passages. some of which I quoted here. He never provides a reason why he believed in this principle, and probably thought of it as somewhat obvious. For example, before responding to Zeno in Physics 8.8, he says that the Z process consisting of counting infinitely many numbers is, by common consent, homologumenos, impossible. But I do think that it is possible to reach a better understanding of why he might have been committed to it. So my strategy will be this. I shall consider 3 arguments to the effect that Z processes are impossible and try to identify the one that Aristotle would most plausibly have shared. First of all, the first argument I want to consider is an argument we have already encountered in some sense. So one could think that a Z process would take an infinite time to be completed and thus not be completable at all. Now, in Physics 6, we've seen that Aristotle refuted this kind of argument with respect to continuous motion, but the argument might have stronger force once it is applied to a sequence that is discrete. So suppose that there is a minimum amount of time, for example, an individual task can take, that is a task that is not a part of a longer continuous task. If it is so, the sequence of time taken by the motions in a Z process does not converge anymore to a finite limit and thus will occupy an infinite time. Now, interestingly, there is evidence that Aristotle was committed to the first premise of this argument, in particular in a passage from On the Heavens, where he states that for each action, a minimum time is determined that cannot be exceeded. That is, that cannot be such that no other time can be smaller for completing the action. But this reasoning, anyway, cannot be Aristotle's main ground for upholding no infinite steps. The proof lies in the remarks of Physics 8, since, as we have seen, Aristotle there considers the dichotomy independently of time and still asserts no infinite steps. He must have had more fundamental reasons to maintain it. So let me pass on to the second argument. Now consider this fact about infinite sequences. In such sequences, if one reaches a stage where a certain finite number of steps have been completed, there always remains at least one step, and in fact, infinitely many steps, that has not been completed yet. I shall call this feature no last step. Now, Aristotle was surely aware that infinite sequences, whether consisting of continuous or discrete steps, satisfy this property. For example, in Physics 3.6, he says that within subsequences, there will always be something beyond to take. Now, it might be tempting to think that this is a good reason to think that a Z process will never be completed. After all, how we can get to the end of a sequence that has no final task? But note that this involves a fallacy. Even though there's always another step as long as the process is undergoing, this doesn't mean there's always another step full stop. Also, completing a process means completing all of the steps, not necessarily the final steps. So it doesn't really imply that there must be a final step to complete. The question now is, did Aristotle fall into this fallacy? Some scholars have thought so, but I believe there are good reasons to say he probably didn't. And the main reason why I think so lies in Aristotle's response to another famous paradox by Zeno, that is Achilles and the tortoise, though the tortoise was really added probably later than Zeno, surely later than Aristotle. Now, briefly stated, the paradox is this. It is very similar to the dichotomy, but I think Aristotle's response here is interesting. We have a race between Achilles, the fastest person in ancient Greek mythology, and a tortoise, which is clearly much slower. And out of pity, the tortoise is given a head start over Achilles. Zeno notes that before Achilles reaches the tortoise, say at point B in my figure, he must pass through infinitely many points. For as long as he is behind the tortoise, every time he reaches a point the tortoise was before, the tortoise is ever so slightly ahead. Now, Zeno concludes from this that Achilles will never reach the tortoise. But note that this is exactly the fallacy based on no less step that I've just described, because he infers that from the fact that at any stage before he reaches the tortoise is ahead, that the tortoise will always be ahead. But Aristotle seems to be aware that this reasoning does not work. He says, to claim that the one ahead is not overtaken is false, for as long as it is ahead, it is not overtaken. But it is overtaken all the same, if only one concedes that the finite line is traversed. Now, the statement that the tortoise is not overtaken as long as it is ahead is less trivial than it sounds. It might plausibly stress the fact that even though there are infinitely many points at which the tortoise is ahead, and thus no last stretch before Achilles reaches the tortoise, it doesn't follow that there is never a point at which Achilles overtakes it. Indeed, B is exactly such a point, and Aristotle can then refer back to this first solution of the dichotomy to show that it can be reached in a finite time. Now, this already suggests that Aristotle could hardly rely on argument to endorse no infinite steps. But to clinch this conclusion, I shall show further evidence that can be found in other remarks present in Physics 6 and 8. In general, Aristotle seems to hold that it was possible to complete continuous sequences that have no first or last member. He makes this point about first members in Physics 6.5. He says, there is no first part of the time in which the thing was changing. So within a continuous motion, there is no first stretch of time in which the thing started its change. And so there are infinitely many stretches of time before, like after the motion has started. And he implies that the same holds about last members in Physics 8.8, as well as in the Achilles as we have seen. So indeed, it seems that for him, any continuous motion implies the completion of such sequences. Now, one might worry that both this evidence and that provided by the Achilles paradox does not apply to our case, since our case concerns a sequence that is discrete and not continuous. But note that with respect to the specific property we are considering, that is, no last step, there is no significant difference between a sequence whose members are continuous to one another and a sequence whose members are discrete. So it seems valid to draw on remarks about continuous sequences to prove a point about discrete sequences in this case. So I conclude here that Aristotle was not committed to no infinite steps on the basis of no last step. So let me get to the argument I believe best explains Aristotle's position. This argument is a version of a famous thought experiment known as Thomson's lamp from J.E.F. Thomson's 1954 paper. And it raises a difficulty for the end state that a Z process would reach if it could be completed. So Thomson described this funny case. Suppose that it is possible to complete the process of switching a lamp on and off infinitely many times. In which state would the lamp be when the process has been completed? The very least we could say is that the final state is not determined by the given process, since each step of the process only determines the state of the lamp at the immediately following step, but the final state has no immediately preceding step. Now, even if there is no outright contradiction, it is still a very puzzling situation and might be given as a reason to endorse no infinite steps. One could regard as impossible a process that does not lead to any definite outcome, apart from the trivial outcome consisting in all of its steps having been completed. Now the question is, could Aristotle have thought something like this, and particularly in the case of infinite sequences like the dichotomy. Before going back to the dichotomy, let me consider the question more generally. There is an important principle, I think, of Aristotle's theory of motion that seems directly relevant to the matter. I call this boundedness, and it is the principle that every motion occurs from a starting state to an ending state. Aristotle says, ektinos est, and it is constitutively directed towards an ending state, though it might in fact end at another ending state due to being interrupted. This entails that there cannot be a motion with an infinitely long path, because such a path would not lead to any ending point, since there is no ending point at all. And Aristotle holds that it makes no sense to say that a motion is occurring towards a point that cannot be reached, as he claims in the passage from Physics 6:10 that I quoted here. He says, "No change is infinite, for every change is a change from something to something. This is boundedness." And he says, he justifies this by saying, it is not possible that which cannot have changed should be changing, metabalein, in present tense, to that to which it cannot have changed, metabalein, in aorist tense. Consequently, its motion is not infinite, and it will not be in locomotion over an infinite distance, for it cannot have traversed such a distance. Now, it is quite intuitive to think that Aristotle could have thought the same about infinite sequences that do not tend to a limit, such as the switching on and off of Thomson's lamp. Now, the trickier question is whether he could have reasoned in the same way, more or less, with an infinite sequence such as that of the dichotomy, which does have a limit to which it tends to. The fact that Aristotle doesn't really seem to make a difference in the assumption of no infinite steps in these two cases suggests an affirmative answer, but it still remains to explain how exactly this should work. And this is what I'll try to do now. So let's finally return to the dichotomy. We can note now a difference between the continuous motion over AB and the discrete sequence of infinitely many discontinuous motions over the segments within AB. The former includes the endpoint B of the path, whereas the latter does not. In other words, their paths respectively correspond to a closed interval and to an interval that is open with respect to B. Now, as recent studies have pointed out, there is evidence that Aristotle could have noticed this difference, since it could distinguish between an open and enclosed interval. In particular, something he noted is that the limiting instants of a motion do not belong to the interval in which the object is moving. So this interval is open, and the limits belong to the preceding and following intervals of rest that are closed. He makes this point specifically with respect to the final instant in the text that I have quoted, which is again from Physics 8:8. He says, "It is true that the point, that is, the final instant of motion, is common to both, that is, the motion and the rest. But so far as the object is concerned, to the pragmati, it always belongs to the later affection." Now, one could think that this passage actually goes against what I'm trying to establish. If all motions starting with continuous ones do not include their boundaries, then what is the problem if our infinite sequence doesn't? My reply is that in the passage I've just read, Aristotle is not really claiming that the motion does not include the boundaries, so the continuous motion, I mean. He's only claiming that the object is moving in the open interval between the limits of its motion. And indeed, he seems to claim that the boundaries, insofar as the motion is concerned, are common to both the motion and the respective periods of rest. It is only insofar as the state of the object is concerned, the pragma, that they belong to the rest alone. On the contrary, the repeated insistence on the principle I mentioned before, boundedness, that every motion is defined by two boundaries, suggests that Aristotle conceived of motions as completed acts, so to say, that go from one point to another, even though the subject of motion is at rest at those points. So, in conclusion, I have already noted that argument 3 explains well the assumption of no infinite steps for Z processes that do not tend towards a limit. On the other hand, in the dichotomy case, Aristotle cannot really say that there's no limit where to arrive, because, of course, the sequence tends towards the limit B. But as I have tried to show, it still matters that B does not belong to the interval covered by the sequence. Specifically, Aristotle might have thought that what's wrong with such Z processes is that even though they seem directed towards an outcome, they don't lead to the outcome they are directed towards, since no single step within such sequences does. Of course, it is difficult to provide conclusive proof for this hypothesis, and my inquiry remains speculative to an extent. But I hope to have shown that this is a plausible reason why Aristotle agreed with Zeno on the impossibility of Z processes, a reason that is tightly connected to his general views on motions and their limits. As a concluding note, I wish to bring a bit more to light a parallel that perhaps has surfaced in this last part of the talk, that is the parallel between Aristotle's and Thomson's analysis of the paradox. While studying this, I find it very striking that if my reconstruction is correct, not only Aristotle's position on infinite processes, but his specific assessment of Zeno's dichotomy in Physics 8 is very close to Thomson, without the latter or later participants in the debate being apparently aware of this. I put it here what is Benacerra's summary of Thomson's assessment of the paradox, and I'll let you judge the similarity between the two by reading it out. If we have made a continuous uninterrupted journey from A to B, we can be said to have covered all the stretches described in the first premise. If there is at least one of those stretches that we haven't covered, then we haven't completed the journey. In this sense, the first premise is true. But in this sense also, the second premise is false. Completing infinitely many journeys takes no more effort than completing one. If, however, we think of completing an infinite number of journeys as completing an infinite number of physically distinct acts, each with a beginning and an end, and with, say, a pause of finite duration between any two, then according to Thomson, the second premise is true. It is logically absurd that one should have completed an infinite number of journeys. But of course, under this interpretation, the first premise is obviously false. One need not complete an infinite number of journeys of this kind in order to complete a single one. Thank you for listening. Yeah, I concluded with a funny. This is Zeno.
Yes, thanks, Martina. So please raise your hands and
Yeah, just a second. I don't know how to stop the.
oh, you can just hit the share button, hit stop. But also, if you
Oh,
keep,
okay, perfect. I
yeah,
made
yeah,
it. Yeah, or perhaps it would be helpful yeah,
as
I don't
well.
know. In case I'll share it again.
All right. Thoughts. Ah, yes, Andrew. Very good.
Um, Thank you for this talk. I know that you just turned off the share, but I was wondering if you could go back to the second/third to last slide with the
Perfect.
conclusions.
Yeah,
And
that's great. Yeah, just a second. Sorry.
no, I'm sorry.
Yes. Okay. This one.
Yeah. And just explain that third conclusion just a little more again.
So the idea is, as I said, like it seems to me that like the principal boundedness about motions and the fact that Aristotle already infers from that that there cannot be a motion with an infinite path already explains why we can't complete, and I mean completing an infinite sequence of tasks that like does not tend towards a limit. So if you take, for example, counting like every natural number, it's not that Aristotle doesn't think, for example, I think there's an interesting passage in Physics 610 where he seems to say that if we mean performing the sequence in the sense of like having it like in such a way that at some time each of the task in the sequence is done, then having an infinite time, we could perform the sequence, so to say, but that is not what it is to complete it. And in this sense, like the sequence can be treated sort of as a single motion, in my opinion, and boundedness applies. So like since it doesn't go towards that, there is no ending point towards it goes, then it is impossible even to sort of start performing the sequence meaningfully. Now, my, let's say, more complicated attempt was trying to show that he might have reasoned in the same way, even with processes that do tend towards a limit. But insofar as they are sort of discrete sequences, so insofar as they are not embedded in a continuous process that, as being continuous, includes in its paths the ending point, I think Aristotle might, like my claim is that Aristotle might have assimilated the sequence to the first case, so to the case where there is no final limit. Because it seems to me that, as I said, for Aristotle, it is really important whenever we talk about a motion and whenever we assess the possibility of a motion, that the motion is defined with reference to the ending state it goes towards. But if you describe the sequence of discontinuous motions themselves, the ending point is not included, is somehow external in a way in which it is not external to the continuous process. I don't know if like that helps.
Yeah, is this right? You're suggesting that the sort of all motion is towards an end is really the fundamental underlying premise for his thought and all these things on infinites. Am I understanding you rightly?
Yeah, it is not really like I don't want to stress too much the sort of, because it might seem like a very teleological principle stated in this way, like all motion tends towards an end. And of course, like it is a separate discussion whether like the extent to which teleology is important in this analysis of motion. But the point is that if we agree that any motion tends towards an end, either tends towards an end or has an end insofar as it is interrupted, then an infinite, a structure that it is either a motion with an infinite path or an infinite sequence cannot fit there. Because if it is interrupted, then it turns into a finite motion. And if it is not interrupted, it doesn't go towards, or it doesn't lead to, I used to the expression of leading to in the sense that no, there is no sort of part of this motion that connects directly to the final point. And I think that would have been like a serious problem for Aristotle.
Well, thank you.
Anyone else? All right, well, Martina, I guess I made the misfortune of putting you in with all the Thomists in the morning block, and maybe they have less to say about Aristotle. But thank you so much for your talk and for making the time to join us. Um,
Thanks to
these will
you.
go these will go up on YouTube, so there may be further questions there later.
Of course. Thank you.